Today we're going to be exploring domain and range from a graph. Now the way that I really like to do this is I like to try and take my shape, here it's a circle, and I'm actually going to try and contain it in a box. Now this is not the color I wanted for my domain. I wanted green for domain. I'm going to do red for range. So I try and contain it in this box. Now this would be my left and right sides, and then my top and bottom sides would be contained here. Oops. Here's the top, and here's the bottom. Now you can see that inside of the box that I just created is every piece of my shape. Like I've just created a little home for it. And this is my domain and range. This is the container that my shape lives in. The reason why I do this is it really helps me with understanding how to do this. So I have -2 on this side. This is a hard connection, -2, and I have +2 right here. So I know that my shape runs from -2 to +2 for my domain. For my range, I have 5 as my high value, and I have 1 as my low value. So I know that my shape must run from 5 to 1. The way we actually write this in mathematical terminology is we just write -2 is less than or equal to x, which is less than or equal to 2. And over here we write 1 is less than or equal to x, which is less than or equal to 5. Except this would not be x, it would be y. Here again, we're going to be looking at two things from a graph. First, we're going to start off with our domain and also our range. Remember, I like to contain my picture, my graph, into a box. So my domain is going to be the left side and the right side. So I see my shape goes all the way to the edge here and then to the 4 right here. So I'm going to draw 2 lines there. I'm going to put a hard circle right here and an open circle here because I know that it touches, but it goes through this side. Let's go for the top and bottom. So the bottom of my shape, again, it starts here, so it doesn't go any lower than this spot. And then this seems to be the highest portion here. Let's get that line to be straight. But again, I'm going to do an open circle because unlike the last example, not everything is contained inside this area. Because this has an arrow here, we know that my shape continues to grow going outside. So this edge, this left edge, and the top edge are kind of false edges, which means that instead of stopping here, we can actually draw an arrow saying, hey, I know things grow outside of these boundaries. This shape just continues forever. So let's stop and think about what is forever. Forever in this direction would be -infinity. Right here is 4. Down here is at 0. That number is 0, so this is 0. And if I go up forever, that's +infinity. So my range goes from 0 to +infinity, and my domain goes from -infinity to 4. Here's my domain, and here's my range. Again, the way we actually want to write this out is using mathematical notation. So my domain would be written as -infinity is less than x, which is less than or equal to 4, and my range would be, this one's the small one, so 0 is less than or equal to y, which is less than infinity. All right, again, we're going to be looking at our domain and range. Remember that my domain is going to be the left side of the graph and the right side of the graph, whereas range is going to be the highest point of the graph and the lowest point of the graph. Now, we need to decide if these are going to be hard or soft. So there's a circle here, which means that I don't ever reach this corner. So I'm going to say that this is going to be an open one here. This is a closed circle, so I'm going to say this is closed. Now, for the top and bottom, it's a little more confusing. While this is open, meaning that this part of the graph never actually goes this low, if I follow it along, this part of the graph does go that low. So I'm going to have a hard circle here and a hard circle here. Now we just need to identify the numbers. So this is at -5, right there. This is at 5. The bottom is at -2. And the top is at 2. Now, really fast, let's just think to ourselves, does this actually contain the whole graph? Or is there a part of the graph that shoots out like this? Or maybe this side shoots out like this? Nope. We got it all. So we're fine. So let's actually go ahead and put this into mathematical notation. So I know that this is defined as my domain, and here I define my range. So in order to actually write my domain, what I'm going to do is I'm going to say -5 is less than. Because this is open, it never touches. We don't say less than or equal. We just say less than x, which is less than or equal to 5. Here, in fact, it does touch, so we can say equal. For my range, I'm going to say -2 is less than or equal to, because this is closed, y, and then I have negative y is less than or equal to 2. I hope that helps. All right, we're going to be looking at domain and range, so I want to look at my leftmost portion for my domain. So that's going to be over here, and then my rightmost portion is over here. Okay, and then I want to look at my tallest and lowest parts of the graph for my range. All right, now you might think, like before, that we've actually contained every part of my graph in this area. You might think, yay, we did it. But you'd be forgetting something. You would be forgetting that we have 2 arrows here. Now these arrows indicate that I'm in fact going out of both of these edges here. So this line continues forever in this direction, and this line continues forever in this direction. Meaning that if I was going to have my edges here, let's do domain right now. Let's just focus on domain. Does my graph break my edge? It does. In fact, it will continue forever in this direction. Does this one break my edge? Yes, it does. It'll continue forever in this direction. The same with my top and bottom. These are actually a little bit easier. This one, this edge gets broken by this line. It just goes right through it. And this edge here gets broken as well. It just goes right through down here. There's nothing stopping this graph from ever going up or ever going down, ever going left or ever going right. So the numbers that we have would be -infinity, +infinity, and -infinity down, and +infinity going up. There's nothing that stops these things. This is why I go from -infinity to +infinity for both up and down and for left and right. How do we actually write this? The way we write this is we put -infinity is less than x, which is less than infinity. And for my range, I say -infinity is less than y is less than infinity. And what this tells us is there is nothing containing this squiggly graph line right here is going to go up and to the left and to the right and down forever. There's nothing containing it.